the spinal cord, which is in the central nervous system, from the sensory receptor.
The interneuron connects the sensory neuron with the motor neuron.
Motor neuron conducts the impulse from the central nervous system to the effector.
Resting potential is when the neuron does not conduct impulses. It has high sodium ion concentration outside and high potassium ion concentration on the inside of the axon. Sodium and potassium pump maintains this distribution.
The polarity is -65. Action potential is when a stimulus surpasses the threshold and resting permeability is disrupted. The sodium gates open up and sodium ions rush into the axon, which is depolarization. After the sodium gates close, the potassium gates open and potassium goes to the outside of the axon. Repolarization causes the voltage difference to become negative again. The potassium gates now close. The refractory period is when the activity of the sodium and potassium pump return to their original positions. All happens at the nodes of Ranvier. The nerve impulse goes to the axon terminal where synaptic transmission takes place.
Action potential reaches axon bulb. Presynaptic membrane becomes depolarized. Calcium gates in the membrane open. Calcium ions flow into the axon bulb. Proteins pull the synaptic vesicles to fuse with the presynaptic membrane. Neurotransmitters are released into the synaptic cleft by exocytosis. Neurotransmitters diffuse across the synaptic cleft. Neurotransmitters bind to receptors on the postsynaptic membrane of the next neuron. Postsynaptic membrane is depolarized when there is an excitatory neurotransmitter or hyperpolarized when there is an inhibitory neurotransmitter.
How drugs affect the nervous system.
Drugs affect the limbic system and the action of a particular neurotransmitter at the synapse. Drugs cause the neurotransmitter to leak out of a synaptic vesicle into the axon terminal. It promotes the release of neurotransmitters into the synaptic cleft and also prevents the reuptake of neurotransmitters by the presynaptic membrane. It blocks the enzyme that causes breakdown of the neurotransmitters or binds it into a receptor. Alcohol affects brain chemistry by altering levels of neurotransmitters. Transmitters are either excitatory, meaning that they stimulate brain electrical activity, or inhibitory, meaning they decrease brain electrical activity. Alcohol increases the effects of inhibitory neurotransmitter GABA in the brain. GABA causes the sluggish movements and memory lapses when you drink. Alcohol inhibits the excitatory neurotransmitter glutamate, which results in psychological slowdown. Alcohol increases the amount of chemical dopamine in the brain's reward center, which creates a feeling of pleasure when someone drinks.